Welcome to the Explainer. Today, we are finally taking off the training wheels. We're going to execute your very first state-changing Solana transactions directly through the command line interface. Up until now, you've probably spent most of your time just reading data, right? Querying account states, checking balances, essentially playing it safe. But today, we're shifting gears. We are going to learn exactly how to construct, sign, submit, and monitor basic transactions. This is honestly where the magic happens. It's where you actually interact with the blockchain and leave a permanent mark on the network. Here's our game plan for today's experiments. First, we'll cover moving from observation to action. Then, we'll prepare our test lab. After that, you'll run your first CLI transaction. And finally, we'll verify the state change.
All right, section 1, from observation to action. Let's talk about what actually happens when we transition from passively watching the blockchain to actively writing new data. Think of it like this. Running a query, like checking your balance, is basically just window shopping. You're reading a static snapshot of the blockchain at one specific moment in time. But a transaction, that is swiping the credit card. It's the active mechanism that writes a completely new snapshot. You're moving from just looking at a ledger to fundamentally changing the network state and actually moving the soul. And the cool part is, because you already know how to inspect those account fields, you're perfectly positioned to verify the results of the transactions we're about to submit. Okay, moving right along to section 2, preparing the test lab. Before we do anything crazy, we absolutely need to set up a safe testing environment. Just like any rigorous engineering discipline, getting our environment set up safely is paramount. We're going to build out our safety equipment using 3 precise steps before we execute anything. Step 1, we explicitly connect to a DevNet RPC endpoints or a local test validator. We definitely don't want to accidentally spend real assets here. Step 2, we create a specific key pair just for this test. And step 3, we fund it with some test SOL via an airdrop. I want to zero in on step 2 for a second. The crucial point here is that we use an ephemeral key pair. Basically, this is a disposable test identity. It's a temporary, short-term cryptographic key used strictly for testing. The golden rule, never, ever reuse your long-term mainnet wallet for these kinds of basic development exercises. By generating this temporary key, you isolate your testing environment entirely. Once the experiment is over, you just discard the key pair without a second thought. It is literally the ultimate protective measure for your real funds. Let's look at the engineer's reference sheet for this setup. First up, the Solana config get command. This acts as our compass, verifying we are indeed pointed at the DevNet URL. Next, Solana keygen new. That's the command that creates that ephemeral key pair we just talked about, writing a new file to your machine. Then, Solana airdrop 1 requests test funds from the network's faucet. Finally, Solana balance is our sanity check. It confirms the test funds actually arrived and we're ready to proceed with the real experiment. Which brings us to section 3, your first CLI transaction. The lab is funded, everything is verified, it's time to actually move some SOL across the network. Submitting the Solana transfer command is the moment of truth. This is what officially initiates the state change using your active key pair. You just plug in the recipient's public address and the exact amount of SOL you wish to move. When you hit enter, the CLI takes over. It grabs your configured ephemeral key pair, constructs the transaction, cryptographically signs it, and broadcasts the whole thing straight to the DevNet cluster. Now, what's really fascinating here is the architectural distinction between who pays for the transaction versus who actually authorizes it. By default, when you run that simple transfer command, the CLI assumes your active key pair is doing double duty as both the signer and the fee payer. But these are distinct roles. The fee payer is the account whose LAMP ports are deducted to cover the computational cost of the network processing the transaction. The signer is the entity cryptographically proving they actually have the authority to manipulate the accounts involved. For complex applications later on, splitting these two roles is going to be incredibly powerful. All right, section 4, verifying the state change. Generating a transaction is great, but it's only half the job. The other half is analyzing our lab results. Let me pose a critical question to your inner engineer. The terminal says success, but how do we conclusively prove it? We know we transition from observation to action, but in a decentralized network, we can't just blindly trust our local command prompt, right? We need to verify that the network consensus actually reached the desired commitment level. Your proof is the transaction signature. Think of this as your receipt for the experiment. When your transfer command completes, it's going to output a long alphanumeric string.
You absolutely must capture that signature because it's the unique identifier for your specific transaction on the Solana network. By taking that signature and using it with confirmation commands and log streaming tools, you can peer directly into the blockchain's history. You can see exactly how your transaction was processed and mathematically confirm that the state was irrevocably altered.
Now, if your experiment throws an error, don't sweat it. We've all been there. Just rely on these standard troubleshooting steps to debug the failure. First, verify your active cluster with Solana config get. Maybe you accidentally pointed back to mainnet. Next, check your balance. Maybe your airdrop didn't process, leaving you with insufficient funds to act as the fee payer. Sometimes the network block hash just expires before your transaction confirms. And if you're interacting with more complex smart contracts, streaming your execution logs is your absolute best tool to uncover any deep program-level logic failures. So, having successfully written a brand new snapshot to the blockchain and verified your receipt, the ultimate question remains: what are you going to build next? You now possess the foundational engineering skills to not just read the Solana blockchain, but to actively participate in it. You understand the fundamental difference between reading and writing, you know exactly how to configure a safe ephemeral environment, and you can parse the logs to prove your success. The tools are in your hands now. Happy building, and I will see you in the next explainer.